Okay, hello everyone. So good morning. So are you ready for the presentation? So we'll start our presentation now. We can only Tava is not here, right?
Yes, only Tava.
Okay. All right. So let's see who's the next who has to present. Okay, Trisha. Trisha, are you ready?
Yes, teacher.
Okay, so I will let you present. Share your screen.
Oh no, wait, teacher. I need to switch.
Okay.
Okay, I was a little bit dumb. Sorry.
Okay.
Okay. Can see your teacher.
Yeah, I can see.
Okay, I'm gonna start now. Hi guys, my name is Krisha from class 4S. Very good morning to Pan Youth, my fellow friends. My name is Krisha from class 4S. And for the project this time, I made a hydroculic lift, which was kind of new to me, so it's fine. Let's see how it goes. Yes. Welcome. Are you excited for a fun learning session? Please, someone say yes. It's okay. These are things you need for my presentation now. Make sure you have the following before we start, which are 2 little cute ears and your big eyes. Yes. Next. So first I'm going to talk about the introduction, then the principle, concept of Pascal's law, material, pictures and videos, explanation, modification, and result and reference. Okay. So for the introduction, what is hydroculic lift? It is this lift that you can find. It is these lifts that you can find at shopping complex mostly. Yeah, you can find at shopping complex mostly when they want to like stock up the very high, yeah, their storeroom, yeah, something like that. Okay. So it's a device of moving object, meaning you can put something on top here, and from down here you go all the way up. Yes, and it is the force that is used to create this pressure is by a liquid, and then inside a cylinder that moves the piston upwards. This one I will explain later because it is in the next slide. Oh no. So for my hydroculic lift, I needed to use the Pascal's law. So what is a Pascal's law? Pascal's law is a law that was invented by a French scientist named Blaise Pascal. This is Blaise Pascal. Um, he found out that Pascal's law generates force and motion by compressing liquid by compressing two liquids with a piston in the middle. So when you press them, the the pressure is equal all the time. It wouldn't be lost. Something like that. And according to Pascal's law, in a hydrophilic system, a pressure exerted on a piston produces an equal increase in pressure on another piston in the system. Meaning, if you, I think it's in the next picture. Sekejap, ah. Okay, this is the concept of Pascal's law. It's supposed to be here. I'm sorry, guys. So, as you guys can see here, this is the liquid, and this is the piston. The green color, and the pink color is the piston. Okay, so when you apply force at the A here, the liquid will be compressible. It will be compressible, and then a large amount of force will be created on the right side. Because when you press here, the force and the pressure will travel all the way to here and it'll push this up. Yes. So work is given by the product of force and the distance moved. The force is magnified and the distance moved reduces by the same factor. So for my project, the materials that I used were popsicle sticks, syringe, wooden skewers, tin tube, and paper clip. Because I couldn't find wire in my house, so I used paper clip. These are the steps. Okay, first I needed to prepare the materials, and then I drilled three holes on the ice cream stick. Connect the center point of two sticks with the paper clip. This one I'll show you guys in the video how I connected them. And then I have to connect two ends of each pair so that you have two pairs of overlapping stick. Repeat with the other half. Combine the two sides and insert a wooden skewer and apply some hot glue gun on the end of the wooden skewer to prevent them from slipping. Next, glue the wooden skewer with a piece of cardboard. Get your syringe attached to a tube. Fill up on off the syringe with water. Hot glue the empty syringe to the wooden skewer. I'm sure you guys don't understand, but then I think in the video it's much more easier to make you guys understand. We are here. No, no, no. Shh, 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 shh. Okay. So yeah, this is my end result. Wait, I can't make it big. Let's try to make this big. Oh no. Let's just make it big for now. Okay, let's go to presenting mode. I'm sorry, teacher. Kita. my fellow friends. I'm Krisha from Class 4S, and today I'm gonna explain to y'all okay, can you guys hear? For pastel. No, we
We
can't
can
see.
Yes,
hear, but we
we
cannot
cannot.
see.
You can't see her.
Okay, now we
Okay,
can.
can hear.
Now can I? Okay, so easy. Okay, we will just watch. Okay. Hi, Yuskalina and my fellow friends. I'm Krisha from Class 4S, and today I'm gonna explain to y'all the model that I did for Pascal's law. So basically, this is my model. It's a hydraulic lift. It is made out of a jumbo ice cream stick, satay sticks, cardboard, a string, two strings, one tube, and I used paper clips as wires because I couldn't find wires. And yeah, we had to DIY, you know. So basically, we have my syringe connected to the satay stick here. I mean, I hot glue gun. I don't know if you guys can see. Yeah, it's hot glued to the satay stick. And you guys are going to see the magic. Why do I have a syringe here? Am I going to poke somebody? Or am I going to inject somebody? Oh, no, no, no. Calm down, friends. I am going to show you guys how this flat thing is going to magically go all the way up. You know, even I got surprised. Okay, I'm talking too much. Okay. Yeah, so now the magic is gonna begin. We're gonna start with applying pressure here, and you guys will see it, okay? And I'll explain in a while. As it is, but once in a while, let the reminiscence brighten this melody. Things riding on the lonesome breeze, like the days gone too far for us to see. Like the waves riding on the lonesome breeze. Okay, so basically how this magic works is that it is based on the Pascal's law. Now what exactly is the Pascal's law? The Pascal's law says that the pressure that is applied to a container filled with liquid will be transmitted without losing any force in all direction. Meaning the pressure that I apply here, it will not lose, and it will be transmitted through this tube, and it will push the piston upwards. The pressure that is applied to this syringe over here, and when this pressure is applied, the pressure will be transferred to the statistic, making it causing it to move inwards, and the popsicle stick to also move inwards because of the pressure applied. And so basically, this is how the Pascal law works. So basically, that's all I have for today, you guys. Thank you so much for listening. Thank you for conducting this little project so that you can learn something. And it was really fun. If you guys want to make this, it's actually very simple. Okay, you guys just need some popsicle stick, a satay stick, cardboard, string, some paper clips, or wires, okay, whichever you guys can find during this MCU. You guys can try this out. It's actually very fun. And you guys, oh, I forgot to say, you guys need a very, very strong finger. Like, you, my finger gonna break and forget. But yeah, guys, that's all I have for today. Thank you so much for listening. Bye bye. Yes, that was my mini video. Hope you guys liked it and like learned something from that. And for modification, uh, I know teacher asked to attach pictures, but then I couldn't like do them, and I'm really sorry, teacher, because I don't know, I'm just really sorry. Okay, but then I tried to use my brains, and my brain said you can use a better base because as you guys can see in the video just now, I used cardboard as the base. And when I pushed it, the cardboard always lifted up. So I think you should use a better base, a more hard and more stable base. And then for the string, I think we can add more string so that there is more force applied and it will move faster. And then add a shorter wooden skewer. As you guys realize in the video also, it's kind of like a long wooden skewer, so the distance between the popsicle stick made it even harder to go up also. So I think if you use a shorter one, the more force applied, the faster it can go up. Uh, these are my resources. They were mostly internet and physics
Krisha,
textbook.
you are presenting.
Okay. When did the presentation stop? Hi, you guys can see me now? You
Yes.
guys?
Yeah, can already.
Okay. So, should I restart or I just go ahead lah, because it was just words just now? Yeah, these are my additional resources. And that's all for today. Thank you for listening to me. Bye-bye. 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 Bye-bye.
Bye bye.
Okay. All right. Thank you, Krisha. Okay. So wait. Before that, I just want to ask one question. Actually, can I ask what is the relation of the cross section of the string? Okay. To the force. So, what is the relationship between the cross section of the string with the force?
The more the cross section with the force, the more the cross section with the popsicle stick, the more the force.
Hmm? The cross section and the force. So, what is the relationship between it?
It's directionally proportional.
Directly proportional. Okay. All right. So, thank you. So, we move on to the next one. Okay, Farah will not be able to present because she's not feeling well. Okay. So,
Teacher.
yes.
Teacher, you
Oh, I
last
don't. Yes.
yeah,
Uh,
2 weeks
you
ago when
can't see the wheel.
Oh. Oh,
two
okay.
weeks ago when I finished presenting, teacher said on the following class you'll have to ask me questions.
Yeah, yeah. Do you have any question to ask?
No, no,
Uh,
no. As in, like, teacher, we didn't have time, so teacher didn't ask me question about my project. Like,
Oh, if
ask
no
my
question means your presentation is very clear to me. If I have a question, then I will ask. If not, that means I understand mean what your concept is very like very detailed. I can understand, so it's okay.
okay.
All right. Okay, so just now Farah cannot present, so I will just choose another one. Raja Nur Izzati. Izzati, are you here?
Yes, teacher.
Okay, can continue.
Teacher, how to present?
To present.
Uh-huh.
Wait,
I
I'm.
already.
Oh, cannot because I'm presenting. Sorry.
Uh, am I already? It said here Chrome wants to share the contents, but I can share it. I can't share my.
Okay. It said what?
It said Chrome wants to share the contents of your screen with me, but the share button cannot be pressed.
Oh. Um. Are you using Chrome or using what, Mozilla or what?
Chrome, I think so.
Usually, wait. Um, I try to present my.
Okay.
You click this button, right?
Yes.
Then it says the Chrome something like that. You didn't update your Chrome or something. What Chrome are you using?
It
What version?
says present your entire screen, a window, a tab.
Oh, okay. So that one you entire screen. Choose entire screen.
Uh, I click it, but it says share now. Then I click share now,
Mm-hmm.
and it shows the Chrome wants to share the contents. Blah blah. Lepas tu, I I just can cancel but cannot share.
Mm,
Yeah, I think it's because you're presenting.
no, just now I'm not presenting. Also, is same. Okay. Right now, okay, I stop presenting. Can you try to present again?
Cannot.
Share entire screen. Okay.
Oh, okay. Can.
Huh? Can.
Can I have to click on the picture here. I don't
Oh,
know.
you have to choose the screen, right? Yeah.
Oh,
Okay.
can you? Okay. Can you guys see?
Yep. Can.
Yes.
Yep.
Okay. Mm, okay. So this is my physics project. I'm doing a propeller car. So these are the talking points for this project I want to talk about. First, I will talk about the physics concept being used in this project. Next, we will watch video on I am making the propeller car. After that, explanation how physics concept being used, and I will talk about the modification, and I will show you guys the end result. So the physics concept being used in this project, I'm focusing on the concept of inertia involved in this project. So this project show the tendency of moving object to keep its motion in a straight line at uniform velocity. So the Newton's first law of motion has stated that an object will remain at rest or move at uniform velocity unless acted upon by an external force. So I will show you the video on making the propeller car. Can you guys hear it?
Yes.
Yes.
Okay. I will explain on how physics concept being used in the project. So I want to focus on how inertia involved in this project. So in this project, I definitely want my propeller car to keep moving. This will happen due to inertia. Since inertia is influenced by mass, the wheels that has low inertia has make it move so fast and far, then will continue in motion even though when the propeller and rubber band stop spinning before it fully stop. The less mass the object has, the less its inertia. So modification done to the project. This modification is to keep propeller car move in more efficient motion. So the modification is lightweight wheels, so less inertia, less energy needed to get it moving, thinner tread wheel, less frictions to overcome, while the best stability of the car higher, thinner rubber band, easier to stretch, so more potential energy is stored, so the kinetic energy more. Longer propeller provide more thrust. So we will watch video of the end result. So basically my propeller car act upon an object, so it will not keep it moving because Newton's first law of motion has that, like what I was explaining just now. So yeah, that is all from me. Thank you.
Can I see the question again? Sorry, can I see the video?
This one?
Yeah, this one. Okay. All right. Okay. Okay, thank you.
Okay, thank you. Teacher?
Sorry. Okay, so we move on to the next one. Nirupa, are you ready?
Yes, teacher.
Okay. Wait, okay, you can start now.
Okay, so you all can see me presenting.
Yes.
Good morning, teacher and my friends. So this is my rubber band car I'd like to present. Okay, it's about kinetic energy, elastic potential energy, and conservation of energy. So my index is the first part is material used, pictures on making the project, explanation about the project's physics concept, modification done, end result and reference. So my materials used are ice cream sticks, bottle caps, straw sticks, hot glue gun, rubber band, racetrack, and car models and scissors and papers. Procedure: bottle caps, all my materials are prepared, all the sticks are cut into appropriate sizes, all the materials are used to form a car. The car is tested if it can move. The the first the first model and the second model, the car did not move. So the formation of this car is repeated the third time. A racetrack is formed. The car is tested on the racetrack along with different car models. The car successfully moves on the third experiment. So materials used. This is my first model that did not work, and my second model that didn't work either. Okay, this is my racetrack. Okay, explanation on how physics concept is being used in this project. So basically, when the key concepts of this project, okay, this three energy. When I wind up the car's axle, I stretch the rubber band and store elastic potential energy. The moment I release the rubber band, it starts to unwind. This releases all the rubber band's built up potential energy, converting it to kinetic energy, or the energy of motion that powers my car and propels it forward. The conservation of energy takes place when elastic potential energy converts to kinetic energy. The modification done is I shortened the length of the model of the first and the second car model to make sure the car moves and not just rattle when the rubber band was released. Okay, this is the video of my end result. Okay, and these are my references. Thank you.
Okay, thank you, Nirupa.
Thank you, teacher.
Okay, we move on to the next one. Okay, Kritika.
Yes, teacher.
Okay, let's start now. Go to chat.
Teacher can see my presentation.
Yes, can.
So now,
Yeah, can.
okay. So good morning, everyone. I am Kitika Rasikran from class 4S. So today I'll be talking about the working model of traffic light. First, let's see the materials used for this project. You need a piece of plywood, two green lights, two yellow lights, two red lights, and two push buttons, in where the green color will be acting as the on push button and the red color will be acting as the off push button. And you need some connecting wires to connect the electrical components and also the lights. So we need sir, can you see my video
No.
for right here? Now can sir?
Yes, can.
Okay. So So we need three 30 seconds timer, in where you can see the timer here. It actually do not work only with this. You need two components, which is a timer and this, So when you attach these two together, then only they can work. If not, they cannot work. And you need one MCB, the miniature circuit breaker. I think all of you all know about that. And one isolator, which acts as the main fuse for this project. And you need a driller and a hole saw to put a hole in the plywood, and one flower screwdriver and cardboard to make a box. And you need some color paint to do some decorations, and saw to cut the plywood, and cellophane tape, and one contactor. So let's see what are the steps involved in making the traffic light. So first, the plywood is measured using a measuring tape and also a L-shaped ruler. The reason I used a L-shaped ruler is just to make the line to be in a straight line. When you use a L-shaped ruler, it has a 90 degrees, so the line will be straight. And then the plywood is cut using a measured line using a saw. And after that, I put a perpendicular line to make sure the base of the lights are in a straight line. So when I put the hole, the light can sit in it properly. And then I drilled the hole. The hole is put. And after that, I attached a MCB holding plate using some screws using a flower screwdriver. And that MCB holding plate is used to place the one isolator, one contactor, and one MCB and three 30 seconds timer. So after I've placed all the components and I've put all the lights according to the hole, and I've attached the electrical components to the MCB holding plate. I've connected all the wires. So as you can see there, the wires are connected so that the lights can work in a synchronized way. Later I will show the plan of wire connection, like how I've connected. And as you know, when we connect the wires, we need to give a supply to that model. Then only it will work, right? When we need to put it in a plug point, the 240-volt supply will come to the model. Then only it can work, right? So to make sure the live, neutral, and earth wire are connected, I put it in a plug point. And when you put it in a plug, when I make, I sorry, I just attached it to the plug. And when you put that plug into a plug point, the model can work properly. So these are the so this one I just took the measurements of the electrical components. And this is just because, as you can see here, the electrical components are being a bit messy. When you see it just like that, they are very messy. So to cover that up, I'm going to do a box. So the box I just measured, I just take the same measurement that I take in the electrical component. So in the box, I just put the same measurement using L-shaped ruler and a measuring tape. So after all the measurements are done, I just cut the cardboard using a scissor and attached all the parts of the cardboard using a cellophane tape. And after I made the box, I just modified some things, and I made sure that the box is covering up the electrical components. After that, I painted the box so that it looks like an apartment maybe. So, and when you put it in the model, it looks a bit neater and cleaner. And after that, I did some colorings and decorations to make the model look. And as you can see here, this box car is made using a cardboard and hot glue. I didn't have a toy car, so I just did a box car. And this is the box car. As you can see here, this is the main model that I did with the electrical components. Uh, as you can, this is the electrical components. In the next two pictures, I just covered the electrical components. Explanation on how the physics concept being used in the project. Physics concept used in this project is electricity and magnetism. Electricity is involved when the 240 volt of supply is given to the electrical components through a neutral and live wire. When the electric current, alternating current, flows through the solenoid in the contactor, it creates a magnetism. When there is magnetism, the metal attached to the pressing button of the contact, it's not contractor, it's contactor, will be attracted to the solenoid to conduct electricity. During this time, there will be two contacts in the contactor which are normally closed and normally open. So a wire from the normally closed will be connected to the different timers. When different timers have different period, the lights will glow for certain periods, which you will see when I uh, on the video. Okay, I know if I explain like this, no one can understand. So later I will draw a diagram and then I'll make sure you all understand it. So before that, let's see the video. Before seeing the video, let's see the modification done to the project. Actually, this is not the modification that I wanted to do. Okay, the usage of timer instead of relay is not the modification that I wanted to do, but it's also a modification. So, what exactly a relay? What exactly a timer is that? They all carry the same function, but normally in all the traffic lights that you're seeing in the road, they use relay because it has multiple functions. Like in one time, it can operate two sets of uh, traffic lights. So you only need about like one relay. But this timer, they can only operate one set of traffic light at one time. So you need about two timers, three timers sometimes. But this is not a sorry, but this is not a modification that I wanted to do. First, I thought of doing a modification like when a person stands in front of the traffic light automatically changes into a red light. But that was not possible because it involved some electronic things. But the next modification that I wanted to do is that in when you go for touch and go like that, you can see a palang in front of it, right? So if you put a palang in front of a traffic light, that might be helpful for the riders to not be involved in an accident. So I wanted to do that. So for that, you need a reverse forward motor. You can see my cursor. So this is the reverse forward motor. So this reverse forward motor, it has three wires. One is for neutral. I'll explain what a neutral life later. One is for neutral, and the two wires are for the live wires. Let's say if the red light is on it, so which means the motor should move forward, forward to act as a palang. So in order for it to move forward when there is red light, I will join the red live wire into the forward terminal. So in when it's green light, it needs to move reverse, right? So that the cars can go in front. So I need to make sure the green live wire is being attached to the reverse terminal of the motor. But I could not buy this motor because all the electrical shops were closed. And then I searched in Shopee, Lazada, but they only had DC motor, but they did not have a what you call reverse forward motor. And then I also searched whether I can do something with a DC motor or not. So this is a thing that I did. Instead of this tactical switch, I just used a diode in where it changes the AC current into DC current. And you can see my diode here. So this is a diode that I used instead of tactical switch. But this model also did not happen because Actually, this model worked, but the DC motor that I had was about 9 volt and 24 volt. But this diode only gives out 12 volt, in where I can only use a 12 volt DC motor but not a 9 volt or 24 volt. If all the electrical shops open, or let's say they lift up the MCO, I will show like how it works with the Palang. And then this is a video of the end product of my project. So you all can hear.
No, we cannot hear.
No, kita.
Oh, okay, sure. Now can oh,
I warn you and my dear fellow
Yes, I can hear you.
okay, teacher.
friends. So this is my model today that I've worked for the physics project. So this is the working model of traffic light. I have two push buttons, two red lights and two yellow lights, two green lights and cars that I made by myself. And this is the road. So this acts as the model and I've made some decorations here, that's all. So now we are going to see how it's going to work. Let's take, let's on this push button. I've already pressed it on and now you can see that the red light is on, so this car should wait, and the green light is on, so this car can go. So this car can go wherever it wants. And now this car should wait, and now it's red light, so this car should wait here. Now it's green light for this car, so this car can enter this apartment easily. Okay, and same goes like that: red, green, yellow and green, red. So how this is all happening? Is this just a magic or what? So let's see what's happening really. Surprise. So this is the main part here that we are going to talk. So the main reason that is working is just because I've given this 240 volt supply to these lights, okay, through these components. So now we're going to see the specialized functions of all these components. What makes them to be in order to be work automatically. So let's see. So I've given this 240 volt supply to this isolator. This isolator here acts as the main fuse. And as you can see here, I've attached green wire, yellow wire and this black wire. So what exactly they are? This green wire is the earth wire, and this yellow wire is the live wire, and this black wire is the neutral wire. So this earth wire just acts as the safety purpose. So let's say if something happens to the circuit in my house, so that the MCB can off automatically. This is for safety purpose actually. So nothing to talk about the earth wire here. So now we are just gonna loop this neutral wire and live wire to all these components and make these lights to be work orderly. So this is the main part that I'm going to talk. Let's say I'm offing it, and when I'm owning it, you can see that this button goes in, and when I'm offing it, you can see that this button is going up. So here's the live wire and the neutral wire that I've looped to the MCB here. Okay, this MCB also acts as a safety purpose.
So that video is not like a full explanation. And now what I would do is that I will explain thoroughly using a diagram in my whiteboard. So for a while, teacher, I will off my cam.
Can you all see me, the whiteboard?
Yes, you can.
Okay. So the first component that we are going to talk is about the contactor. Okay. This contactor is the thing that when you saw in the video, the button is moving up and down. That is the contactor. So I will show how it works and what are the things that in the contactor. So okay, let's assume that this is the casing of the contactor, and inside this contactor we will have a solenoid. Okay, this is a solenoid, and inside this solenoid we will have a metal. Okay, okay. This metal should be a soft iron or soft metal. Okay, what do you mean by soft metal? Before that, I would like to show like a model, like a thing that I made. Let's say this is a solenoid and this is the metal. Okay, this is how it is being in the contactor. So when you give electricity to this solenoid, this metal will be magnetized. If there is no electricity, this metal won't be magnetized. So in order for that magnet to be a temporary magnet, when there is electricity, and when there is no electricity, it won't be a magnet. So in order for that metal to be like that, it should be a soft iron or soft metal. Okay, what do they mean by soft iron or soft metal is that we have two types of iron. One is a normal iron that we use in where when you give electricity through a solenoid in that normal iron, it will be permanently a magnet. When there is no electricity also, it will still be a magnet. But this soft iron or soft metal like steel, they will only become a magnet when there is electricity. If there is no electricity, they will not become a magnet. So that is the importance of soft iron and soft metal like steel. So let's see how this is all working. So when I give this current supply to this solenoid, this metal will be magnetized. When this metal will be magnetized, we have a special component known as the armature here. This is what we call armature. As you can see here, the thing that I did in the red pen are all the metals. So this armature is a metal. So when this one is magnetized, this armature will go down easily and will be attached to the metal that is magnetized. Whether it is a soft iron or steel, it will be magnetized when there is current. This armature will go down and get attracted to this metal. But there is a problem. If let's say this one is getting attracted to this metal, and when there is no magnetism, this armature will not repel back because it's a metal one. It cannot go up again. So to make sure that it goes up again, we have a spring in between. Okay. So when this metal is magnetized, this spring will also be magnetized, and this what you call armature will go and push the spring. So it acts like a push button mainly, like it push, and when there is no magnetism, it repels back. So that is how a contactor works. And there is another important thing that I would like to tell is just about here we have when this armature closes, this circuit will be closed also. When this circuit will close, just imagine these two circuits are being closed. So there will be a closed circuit and there will be a current flow through that circuit. And another important thing is that when this circuit is closing, let's say there are two terminals here. Okay, in the two terminals we have a metal sheet. I can't exactly get a very good example, but this can maybe can make you all understand better. Let's say this is the metal sheet that we have here. Okay, between the two terminals, one like it is being like this. So let's say when the armature closes, okay, when the armature closes like this, so this will be attached to this metal sheet. So in this case, you can see that one will be attached to that terminal in where it there will be a current flow in that, and another one will not be attached to this circuit. So this is what we call normally closed, in where it will be a closed circuit, and normally open in where it opens normally and there is no current flow in that. So in this part, when the armature is closing, we call it normally closed. Normally closed means normally closed, there is current supply. There is current going on there. But normally open means there is no current. There is no current going on there. So this is what exactly a contactor look like. And the second component that I've made is the timer. Timer plays a very important role in this project. So what's the timer? So timer plays a very important role in this project. We have like 8 terminals, 4 up and 4 down. Okay, before that I will take my timer and come for a while. Okay, so this is the timer that I showed you all just now. As I told you, this timer cannot work without this component, right? Like this component will be attached to this timer, then only it can work. If not, it cannot work.
So
So
sorry, Tiga.
yes, teacher.
Um, wait. Can I ask what subject after this?
Sejara, I
Do
think.
you have a meet?
Yeah.
Oh, okay. Actually, I really like to hear your presentation. Very good. Okay. Can I be continued tomorrow? I would like to know more. Actually, is it
Uh,
okay for you?
okay, teacher. I
Okay.
will. So I will present it from the timer part. Okay.
Yeah, yeah. Okay.
Okay.
So tomorrow we continue with critical presentation. So after that, we continue. I will listen. Okay.
Teacher tomorrow cuti, right?
Ah, tomorrow is cuti ah. Oh my gosh. What? You mean what cuti? Oh, see, I also don't know. Okay, so means we have to continue next week. All right.
Okay, teacher.
Okay. Sorry. Okay. So take care, everyone. Okay. So I see you next week. Okay. So bye.
Okay, teacher.
Thank you,
Thank you.
teacher.
Teacher, bye teacher.
Bye. Bye.